Today I am going to teach you a problem on flow through pipes. So before that I would like to explain you what is the formula or what is the basic formula based on flow through pipes. So today we are going to study about what is major loss and what is minor loss. Before that, what do you mean by head loss? Before that, I would like to explain what is Bernoulli's. I will not explain, I will explain in last class. I am just going to tell. As per Bernoulli's principle, the energy at the inlet of the pipe is almost energy at the exit of the pipe or the outlet of the pipe. This was based on the principle or on the types of fluid or on the assumption which the fluid is incompressible and non-viscous. The fluid which is incompressible and non-viscous is nothing said to be as imaginary fluid. Whereas for fluids which is same incompressible and viscous fluid which is nothing but real fluid, Bernoulli's principle states that the energy at the inlet of the pipe is not equal to at the outlet of the pipe, because since the fluid is a viscous fluid, there is some amount of resisting force acting between the layers of the fluid when the fluid is in motion. Now, the force required to overcome this resisting force will be more. So what happened? More amount of heat is generated, temperature also rises, and there occurs a head loss. Head loss means energy. There is amount of energy loss, that is head loss. So we had the equation, whereas for in case of first case we had, this is my first case, that is non-viscous imaginary fluid, where the energy was written as P1 by rho g plus V1 squared by 2g plus H1 is equal to P2 by rho g plus V2 squared by 2g plus H2, or you can write as Z1, Z1 or Z2. Now if pipe is said to be horizontal, then Z1 is equal to Z2. We have the equation P1 by rho g plus V1 square by 2g is equal to P2 by rho g plus V2 square by 2g. Now in case of second case, when there is a real or viscous fluid flowing wherein occurs a head loss occurs, the equation goes P1 by rho g, in case of pipe is horizontal, V2 square by 2g, where Z1 is equal to Z2. So here P2 by rho g plus V2 square by 2g plus head loss. Okay, now let me explain what is head loss due to friction. What is head loss due to friction? Head loss due to friction. As I said, when the fluid is said to be a viscous fluid, there is some amount of resisting force acting between the layers of the fluid. This acting force is nothing but friction. And similarly, there is a resisting or a friction acting between the layers of the fluid and the pipe. This is supposingly the layers of the fluid and this is the pipe. There is amount of friction occurring between the layers of the fluid and the pipe. Cases happen when the pipe is rusted. Okay. Or it has been used for a long time and mainly for rusted only. Now this head loss due to friction comes under major losses. Comes under major losses. Now there are two equations or two formulas used to derive or to explain or to calculate the major loss. First one was by Darcy Weisbach and second by Chessie's formula. Now I'd like to give you more highlight on Darcy Weisbach equation. It states that now your head loss due to friction is denoted by HF. The formula goes like this as per Darcy Weisbach equation. HF is equal to 4 into F dash into L into V square by 2 into G into D. Now here HF is nothing but head loss due to friction. F dash is nothing but coefficient of friction. L is the length of the pipe. D is the diameter of the pipe. And V is equal to the velocity of the flow. I'll write the units here. There is HF, we'll write in meter. Friction there is no. Length will be in meter. Diameter in meter. And velocity will be nothing but in the units meter per second. Okay. Now, this coefficient of friction can be calculated by two methods. First is 16 by RE. Second is 0.079 divided by, or I can write RE raised to the power 1 by 4. Now what is this two types? The coefficient of friction calculated by two ways with the flow of, as you can see, there are the various types of flow will be laminar flow, turbulent flow, then steady flow, unsteady flow, uniform flow, non-uniform flow, rotational flow, irrotational flow, 1D, 2D and 3D types of flow. But mainly we are going to more stress on laminar and turbulent flow. So what is laminar flow and turbulent? I will explain in our class. When the velocity is more, it is when the velocity of the flow is more, it is turbulent flow. When the velocity of the flow is less, it is laminar flow. Now what is this? You might be surprised. What is this RE? Now why this RE is nothing but known as Reynolds number. Reynolds number is a dimensionless. There is no value, dimension or no thing. It is denoted by rho Vd by mu. This we can write as rho Vd into nu by rho. Rho get cancelled. So we have the equation Vd by nu. So the formula for this goes as inertia force by viscous flows. What is this mu? Mu is equal to dynamic viscosity and nu is equal to kinematic viscosity. When the fluid is in motion, there is some amount of resistance or acting. So we have the equation nu and mu. Now, so our Reynolds number goes as Vd by nu. Now, after calculating this Reynolds number, if the Reynolds number is less than 2000, the flow is said to be laminar flow. And if the Reynolds number comes in the category of greater than 4000, less than 10 to the power 6, then the flow is turbulent. So you might have understood that with the laminar flow determines what type of flow. Mainly when the air is flowing through the wings of the flight, depending upon the velocity and depending upon the calculating the Reynolds number, determine whether the flow is laminar or turbulent flow. So if the is laminar, as I've told you, if the low flow is laminar, we'll get F dash 16 by RE. Then turbulence 0.09 divided by RE raised to 1. So this is the laminar number. Reynolds number. Reynolds number is mainly dependent upon what? Velocity of the flow, diameter, and kinematic viscosity. Clear? Now let us solve this problem. The question goes like this. A crude oil of, I'll write the data here only, where a crude of viscosity, this I write as nu, 0.4 stroke is equal to 0. Into 0. Centimeter per second, centimeter square per second will be written as 0.4 into 10 to the power minus 4 meter square per second. The other data which is given is diameter is given as 300 millimeter. Q is given, rate of the flow is 300 liters per second, and the head and length is given as 50 meter. We need to calculate head loss due to friction. So we need to calculate the formula. We need to calculate HF is equal to 4F dash into L into V square by 2GD. So I'll write here HF is equal to L into V square by 2 into G into D. Now in this equation we don't know the value of V. Since Q is given, I'll write as Q is equal to A into V. That is rate of flow or discharge is known by the formula Q is equal to N. Q is given 300 liters. Now here only I would like to convert it. You can see this, I'll write as 0. 300 10 to the power minus 3 meter cube per second. This I'll write in meter as 0.3 and this is already in meter. Clear? Any doubt regarding this? Now I'll substitute 300 into 10 to the power minus 3. This I'll take the diameter, area of the diameter 0.3 square into V. Now I'll take my calculator. Now before that I'll take 0. First I'll take 0.3 square into, shift my pi is here, divide by 4. I'll get the answer, area as 0.07068 into V. 300 into 10 to the power minus 3. Therefore my V will be 300 into 10 to the power minus 3 divided by 0.07068. So here you can see on the calculator I already got 0.768. Here I'll take inverse of that into 300 10 to the power minus 3. I got the answer as 4.244 meters per second. So the velocity of flow is as 4.244 meter per second. Now what I'll do, I need to calculate HF is equal to 4F dash into L into V square divided by 2 into G into D. Now here for everything I need to calculate the next S. So this is my second S, F dash. Now F dash, two cases are there, 16 by RE if the flow is laminar. Similarly 0.079 if the flow is turbulent. This all determines by the value Reynolds number. Reynolds number is equal to Vd by nu. Vd is given 4.24, D is 0.3 and nu is 0.4 into 10 to the power minus 4. I think it's correct. Now I'll take here, I'll take 0.4, 10 to the power minus 4 inverse into 4.24 into 0.3. I'll get 31800. Matlab 1, 2, 3, 4, 5. It's more than 2000. You can see my Reynolds number is, this Reynolds number is, if it is greater than 2000. So in this case, what is my flow? My flow is turbulent. Hope you understood. Now, so which formula? I will go for the second formula. So my F dash is equal to 0.079 divided by, substitute the Reynolds number 31800 divided by 1 by 4. Now here I need to calculate So I'm just calculating here. I got 31800 to the power 0.25 inverse multiply 0.079. So I got the equation F as 0.0059. My F is dash. Now what I'll do? I'll put in head loss due to friction. HF is equal to 4 into F dash into L square divided by 2 into G into T, which is equal to 4 into F is 0.0059, length is 50 meter, velocity is 4.24 square, 2 into acceleration due to 9.81 meter per second standard, and diameter is 3. Now I'll divide 2 into 9.81 into 0.3, which I got 2 in 9.0.3. This I'll take inverse of that into 4 into 0.0059 into 50 into 4.24 square. I got the equation 3.604 meter. Therefore, head loss due to friction for the given problem I got is 3.604 meter. Hope you understood with this video. I'll come with more video. Thank you.